Now we've learned about this new information structure called a graph, and what we need to do is go off and design a data definition so that we can represent graphs using data. Well, I already said that graphs look a bit like arbitrary arity trees, except they have these additional properties that you can go in circles, and there can potentially be two ways to get to a given node in the graph. But they do look a bit like arbitrary arity trees. Each node has a name and 0 or more paths to get to other nodes. Or since these aren't general graphs, but these are rooms, each room has a name and 0 or more doors that lead to other rooms. So let's design it that way. We'll say that a node or a room is compound data, so we'll use define struct, and each room has a name and doors going out of it. Okay? Since they're going out, let's call them exits to reinforce that they go out. And we need a type comment here, so room is make room. It's a string for the name and a list of room for where you can go to next. The interpretation is the room's name and list of rooms that the exits lead to. Now let's do some examples. And in fact, we're asked to do an example for all of the ones above. So let's do an example for house 1. And that looks relatively straightforward. Let's see, there's a room, make room, called A, and it has a single exit, which leads to a room, make room, called B, which has no exits. And what I'm going to do is I'm going to take all of these here, I'm going to copy them down to here, except I'll move this first one back up ahead of it, just to reinforce what room that is so that when the other thing scrolls off the screen, we can still see it. So that's the first house, H1. Now, let's try to do this one. Let's see, there's a room called A, and it has a single exit that leads to a room called B, and that has a single exit. Wait a minute. Because there's a cycle here in the graph, we got a problem, which is, what I really want to do is somehow manage to put all of this right there. But I can't, because the way we write value expressions in this language is that we need to be able to write make room with its name and the list and all the other rooms right in there. But we can't in this case because A kind of contains B and B kind of contains A. And so there's no notion of which is the enclosing one. Enclose each other. Our way of writing values in the teaching languages that has this notion of enclosing corresponding to the nesting of the parentheses isn't going to let us do this. So how can we get out of this problem? What we're about to do now is we're going to switch to the last of the teaching languages called Advanced Student. And Advanced Student is going to include a special new construct called shared. And what shared is going to let us do is it's going to let us say, in a case like this, it's going to say, well, let me have a kind of special name, -0- for A. So I'm going to make this room, and there's going to be this special name for it. And that name is going to be kind of a promise to refer to this room later. And here, what I'm going to let myself do is say -0-. And now, I'll just produce that room. So read this as saying there's a shared expression. Here's a special kind of promise name. It's a name that we're going to use in circular structure for make room A of list, make room B of list, and then here I'm allowed to use the special promise name -0-. And what the advanced student language is going to do behind the scenes is it's going to make this work out to produce exactly that structure. Let's look at it. Let's try running this now. And let's look at H2. Well, H2 is exactly that. For the same reason we can't write an expression in the old-fashioned way that produces H2, Racket can't show us its value in the old-fashioned way because there's this circular structure. Because A contains B contains A, it's got to use a shared expression to print it out. Now, you may find that thing a little bit confusing to read, and you wouldn't be the only person who finds it a little bit confusing to read. So sometimes when we look at the value of circular structure, instead of trying to read the shared expression that Racket shows us, what we do is instead we say, well, this room H2, what's its name? Room name of H2. And now it's like, okay, that's the room named A. We say, well, how many exits does H2 have? Well, it has a single exit. We say, what are the names of all those rooms? And now I kind of have a notion of what A is. It's this room that has a single exit to a room called B. I can look at it this way if I want. I can look at it that way if I want. It's just a little bit harder to read, although I can pick all of that out. Let's see. There's a shared. There's a special promise name -0-. There's a room called A, which has a list of exits that's a single room called B, which has a list of exits to a single room which is -0-, in other words, the A itself. So that -0- kind of creates a circular line right here on the screen. That's what it does. And then the shared expression says, and I'm giving you back A. So you can read that more complicated structure if you think of the promise names as basically making cycles back in the structure. Or you can use selectors to pick the structure apart and understand it that way. Both are valid. What I want you to do now is write an expression to produce this third example. So write an expression right here, define H3, finish this out right here to produce that third example.